Hi, I'm Chris Modica, an Enterprise Solution Architect here at AWS based in Sydney, Australia. Thank you for joining me today. In my role at AWS, I work with large-scale global software businesses, ISVs, to help them grow and transform their software products and businesses with AWS. Implementing microservice architectural patterns is key to support their global and hyperscale business growth. So, what are we going to cover today? I'm going to start by focusing on the three most common architectural design patterns that emerge with application refactoring or building out new greenfield applications. We're going to cover the API gateway pattern, the Strangler pattern, and the event sourcing pattern. I'm also going to show you how you can combine multiple patterns to accelerate different business outcomes. Through the use of the patterns that we discussed today, you'll be able to take these patterns and learnings to help you transform your modern application architecture, regardless of where you're at on your journey. Be that building out a greenfield application, migrating your existing application into the cloud, or replatforming or refactoring your existing app. I do want to quickly highlight that today's session is a level 300 session. So my intent is you have some familiarity with this topic, and you have good baseline awareness of some of the core AWS services that I will cover. But don't worry, regardless of your level of AWS knowledge, I have a lot of references that I will leave you with today to help you. I also want to highlight in today's session, I'm not going to cover polyglot persistence in detail, as there's another session that covers that topic in depth. I'm also not going to focus on multi-region design concerns, just to keep it nice and simple. So let's jump into it. Let's start by quickly baselining what we mean by building out modern applications and what does great look like. A modern app leverages architectural patterns and best practices. Typically, we'll have a modular service-based design and apply modular service-based design principles. Where possible, it's going to trend towards serverless or managed services first. It can help us enforce developer agility through automated, abstracted, and standardized principles. Continuous compliance is also achieved through programmatic guardrails. Data architecture is typically decoupled and purpose-built. In the time that we have today, I'm going to focus on the first two principles. Now, by joining today's session, you're probably thinking, how do I get from where I'm at today to transform towards a modern application architecture? I'm going to show you some patterns to help you here, but to start with, I do want to quickly highlight that there is multiple pathways. And it's not uncommon to see a mix of different compute options, be that Amazon EC2 or our managed container service offerings like Amazon ECS, AWS Fargate, or AWS EKS. And for the greenfield components, more common than not, we'll start to see AWS Lambda, our serverless compute option. Now, compute option ultimately will vary based on your application workload and operational needs. For a traditional app, it's likely you'll probably start your journey on Amazon EC2 and then trend towards a container-based deployment option for your complex workloads, while starting to split out some of the components and taking a serverless-based approach where feasible. If you're building out greenfield apps, it's likely you will implement our serverless capabilities like AWS Lambda and AWS Fargate, and as I mentioned, our container service offerings. As you can continue to complete these application or replatforming activities, you'll start to move up the value chain and leveraging our higher order services, which means you're delegating more of the shared responsibility to AWS to manage concerns, in particular operational concerns, on your behalf, versus needing to do this yourself. So, what are the architectural patterns that are best suited to help us here? Well, when we're talking about modern application design, more often than not, we're typically talking about transforming to microservices. Whether we're moving a monolithic-based application to microservice architectures gradually, by creating events and APIs. And as you can see, the Strangler pattern is mentioned, but I'm going to come back to that in more detail in a second. Now, one of the common questions I get from customers is, why should I refactor or migrate to a microservices or event-based architecture? So to help you here, ultimately it's all about reducing the size of your deliverables. As you're introducing new change with a microservices design, that change is as small as possible so your application artifact is readily deployable and can be rolled back or redeployed with ease. Now, this approach also allows you to transform gradually and continuously. You probably don't have the luxury of pausing new product releases while you refactor your application over the next 6 to 12 months. This approach focuses on agile delivery best practices, which can help you do less more often. Now, the outcomes or the benefits you're going to achieve here is it enables you to ship incremental value, reduce the blast radius when deployments go to plan or don't go to plan, and you can prove out new product concepts by taking an MVP approach, which allows you to stagger or stage your R&D investment. So how do you go about breaking up a monolithic application? Well, we start with AWS Cloud Native or higher order services. We want to progressively decouple functionality by trying to carve out one component at a time. We want to leverage design patterns that work for cloud or hybrid-based architectures. And for new greenfield development, ideally cloud native, we want to take a serverless first approach. Now, APIs are the key enabler to all modern application architectures. So we're going to start with the API gateway pattern. In a monolithic application, we most likely have a client service-based architecture or a 3-tier web application at play, where client interfaces are talking directly to backend components or services. We start by first introducing an API gateway, in this instance, Amazon API Gateway. Now, initially, this is acting as a pass-through proxy, which implements the facade pattern. This is a very powerful technique as it enables multiple integration patterns to help you transform to a modern application architecture. So let's start by looking at what a modern application architecture looks like with Amazon API Gateway. In the sample in front of us, this is a serverless design with AWS Lambda as our starting compute option and Amazon DynamoDB, our NoSQL data store. Through using cloud-native services, we can start to address operational concerns by using services such as AWS X-Ray and Amazon CloudWatch. This can address our observability needs around log management, operational metrics, and we can look to use capabilities like CloudWatch dashboards to help us monitor our application and platforms end-to-end. Through the use of Amazon API Gateway, we can toggle API requests by using API usage plans to help us regulate or rate limit inbound access. We can look to leverage Amazon Cognito for our API authentication and authorization needs, and we can also choose to implement OAuth 2.0 integration flows. By using AWS Secrets Manager, that can help us by managing our secrets and API keys, such as API keys and database credentials. And by using a fit-for-purpose database, in this instance DynamoDB, and database design best practices, we can achieve significant read and write concurrency and throughput. We can look to implement regional endpoints in API Gateway and leverage newer capabilities like HTTP2 support. Most importantly, through the use of AWS managed services, pricing is based on utilization. And through the use of serverless components, we are not spending money on idle compute time. You can also look to use our Lambda Power Tuning open source tool to help you optimize for cost and performance. And I share that reference with you today. Now, I hear you saying, well, that's great if I have a cloud-native application or I'm building out a greenfield application, but I'm nowhere near that at the moment. I'm running a 3-tier web app on a single server or something to that effect. So how can I work towards achieving a modern application architecture like the one you just showed me. Now this is where our second pattern comes into play, the Strangler pattern. This name was coined by Martin Fowler, the chief architect at ThoughtWorks. Ultimately, the Strangler pattern enables you to move your monolithic applications to microservices by gradually creating events and APIs for various components of the legacy or monolithic application. This allows old system components to progressively be phased out. Now, imagine you have a 3-tier web application. You have clients connecting to a central load balancer, and you're routing downstream network requests to an active-active server configuration, commonly connecting to a relational database and physical stores. You'd like to transform this architecture to a modern application for a variety of different reasons. Now, we actually start by introducing the pattern that I discussed earlier, the API gateway pattern. We can inject the API gateway initially to act as a facade between your clients and your existing on-premise load balancer. We can then look to introduce new network components from there. As an example, AWS's Network Load Balancer, or NLB for short. It's also important that we start to establish a dedicated network link between our AWS environment and our data centers through the use of capabilities like AWS Direct Connect. In this particular model, the NLB is now performing the ingress network routes and operations. And then it's on forwarding to our network load balancer on-premise. We can then start to leverage our observability tooling, AWS X-Ray and Amazon CloudWatch, to help us gain additional insights and help bubble up application metrics with the operational activity of our workload. This is a lot easier than trawling through logs across on-premise physical servers, which are often managed by separate platform or application teams. Through the use of a virtual IP, we can use our corporate load balancer to send network traffic to. We can start to implement our authentication and authorization access controls at our perimeter access point through the use of API gateway and a custom authorizer. This enables us to start to move authentication and authorization out of our backend components and move into a centralized authentication and authorization controller in Amazon API Gateway. This pattern now enables us to gradually shift functionality to new capabilities and platforms. For example, we can look to leverage Amazon RDS, our managed relational data store, in place of an on-premise database. We could also look to gradually move some workloads from our physical servers to AWS by using services such as Amazon ECS and Amazon EC2. As we are in control of the ingress points, we now have a lot more options around how to manage this migration and transition. When we're introducing new functionality, we can look to implement a serverless first approach by using services such as AWS Lambda and Amazon DynamoDB. As you can see, the API gateway pattern, when used with the Strangler pattern, enables a lot of different options and transitional options towards a modern application architecture. And it can also be used, as I've just taken you through, to help you migrate to public cloud. Which brings me to our third and last pattern, the event sourcing or streaming pattern. Now, the base architecture looks similar to the earlier patterns, the difference being I'm starting to introduce some of our streaming solutions. In this particular instance, Amazon Kinesis Data Firehose, which is our managed streaming option. It's not the only one. Kinesis is another option that can work here. This particular pattern is best suited to a variety of different data ingestion needs. Some examples could be ingestion of data files, data events, log files, and a variety of other client data sources. Today, most likely, you're probably achieving similar outcomes by using batch-based equivalent design and commonly with your third-party integration needs and SFTP server. Now, we start with the operational lens. One of the benefits of this particular approach is at time of streaming the data sources, we can take a backup of the raw data and store that immediately in Amazon S3, our managed object store. Depending on our data processing and data ingestion needs, this design pattern is quite extendable and very reliable. By example, we can have a separate data stream for a given bounded domain or bounded context. Once again, through the use of Amazon API Gateway and that API Gateway pattern, we can enforce authentication and authorization at our perimeter through the use of a custom authorizer. Potentially, we could look to obfuscate or remove sensitive data at time of data ingestion before the sensitive data is stored at rest. A good example of using this technique could be to address concerns around the storage of credit card PAN information as it relates to PCI compliance. Now, by storing our raw data files or objects as early as we can in Amazon S3, we can look to leverage more advanced capabilities like AWS Glue, our managed ETL service, to perform data schema discovery and to enable data transforms using the Parquet file format, which is the preferred file format for efficient data processing and data engineering needs. We can also look to use Amazon Athena, our serverless interactive query service, to interact with the datasets as they're stored in S3. From a cost perspective, we could consider introducing message filtering using AWS Glue crawlers to only process data events downstream where needed. Now let's quickly explore how we can combine the event sourcing or streaming pattern to help us transform once again from a monolithic architecture. Now, very similar to where we were before, we start with our 3-tier web application on-premise. We look to introduce an AWS environment and a highly available network link to our on-premise data center through the use of AWS Direct Connect. This time though, we introduce AWS Database Migration Service, or DMS for short. This is used to help us replicate data from our on-premise databases. DMS can be used for one-off migrations, and a lot of you will know it for that. However, it has a lot more advanced capabilities, which can help us with continuous replication or change data capture, CDC for short replication. In this instance, we look to introduce Amazon MSK, our managed streaming service for Apache Kafka. It is being used as the core component for our event streaming compute option and the event sourcing pattern that we went through earlier. From our managed event stream, Amazon MSK, we can leverage a pattern named fanout to distribute data events asynchronously and in parallel into various target data sources. By example, Amazon Aurora, Amazon Elasticsearch, and many others. This is also true of Amazon Kinesis data streams. Now, bringing this all together, we can use Amazon MSK as a target to our AWS DMS service. This is a very powerful application of multiple architectural design patterns, and one that you can try yourself. You can leverage this today to help you readily start to create a data lake in AWS or introduce an event-based or microservices-based architecture. Now, there was a lot that we covered today, so let's quickly recap, and I'm going to go through a whole suite of references for you to work with off today. Through the patterns I took you through, you should now have some ideas around how there are multiple compute options and many pathways that can help you to transform to a modern application or modern architecture. In today's session, we primarily focused on the first two aspects of building a modern application. There are other sessions today that cover off the other topics in more detail. Now, I'm mindful there's a lot to process, so let's go through the references that I have for you to access and download. We're going to start with the AWS white paper on this exact topic. This white paper actually covers the design patterns that I spoke to and several others. Here we have a magic link to my ever-growing list of resources to help you with event-based architectural patterns. Jeremy Daly, one of our AWS serverless community heroes, has another great reference to help you through various modern application serverless microservice patterns. Here's an AWS sample project, which we term the Serverless airline, which is a working reference application which implements most of the modern design patterns that I spoke to you today about. If you leverage this sample app, it can really help you to accelerate your modern application development. If you want to learn more about the integration patterns or other refactoring techniques in a lot more detail, here's 4 great references that cover these topics. Both the O'Reilly text, in particular Sam Newman's recent book, Monolithic to Microservices, covers these integration patterns and related topics and strategies in a lot more detail. Jonathan Allen and Thomas Blood, 2 enterprise strategists at AWS, have produced a text which focuses on modern company transformation and DevOps principles. And Martin Fowler's classic enterprise integration patterns text, while a little bit dated in terms of its publishing date, is still very current in most application refactoring and rewrite needs today. The event today has a great resource hub, which includes the slide pack that I spoke to and many other great references for modern application development. I also highly encourage you to explore our AWS training and certification options. These offerings can help you accelerate your modern application development journey. I hope you found today interesting. Please don't forget to complete the survey. Surveys help us learn what you liked and didn't like, and we actually apply those learnings to future talks and events. And with that, I'm Chris Modica. Thank you for joining me, and I hope you learned something new that you can take from today and directly apply into your business. Thank you.